Hi everyone, welcome back to Newton's Laws of Motion, The Adventures of Tonathan. This is the last section having to do with systems.
A 30 kilogram block is attached by a string to a 10 kilogram block. So this one is 30 kilograms, this is 10 kilograms. Okay. That is being pulled to the right with 3 newtons. Friction is negligible. Like this. Okay, so in this situation, so this is being pulled with 3 newtons of force. So let's try to solve this problem. What is the acceleration of the 10 kilogram block? So when we're doing this, what we're going to do is when we're solving for acceleration, we're going to be looking at the whole system here. Okay, there's no friction, so all we can see is this 3 newtons is carrying both of these. We can let's draw the free body diagram for now, but essentially we don't really have to do that. So this is going to be having a force of 3 newtons, and there's going to be a force of tension here, and then this one just having a force of tension going this way. These two forces of tension cancel out, so we're just going to look at the system. The force of tension just cancel out. So sum of all forces in the x equals mass times acceleration to x. What we have is this force minus force of tension plus force of tension equals mass of both the boxes, because it's going to be pulling both of them, m1 plus m2 times acceleration. So force, which is equal to 3, we don't know what force of tension is, but these two cancel out with each other, is equal to the mass of one, which is 30, plus the mass of the other one, which is 10, and then the acceleration, which we're looking for. Once we do this, we put it into our calculators, 3 divided by 40, and we get 0.075 meters per second squared. The next question is, what is the tension in the rope? When you're looking for tension, when you're doing these system problems, what you want to do is you want to do one part of the system, either this one or this one here. And I guess I'll just do both for this first example. But let's look at this purple one. If I did sum of all forces in the y equals, in the x equals mass times acceleration in the x, I have the only force on this is the force of tension, is equal to the mass, which is 30, times the acceleration of this box, which is 0.075. You can't use the whole system, because if you use the whole system, force of tension is always going to cancel out, and we need to know what the force of this tension is. 0.05. And we get 2.25 newtons. You're going to get the same answer if you did it with this one here. Let's say you use this box here. Sum of all force in the x equals mass times acceleration to x. We have two forces now, though. We have the force applied minus force of tension, going that way, is equal to the mass times acceleration x. Force applied is 3. Force of tension is what we're looking for. The mass of this box is 10, and the acceleration is 0.075. Let's do a little bit of math to figure out the force of tension. 10 times 0.075 minus 3, and we get 2.25 newtons. Okay, so same answer. So again, when you're looking for acceleration, you want to use the whole system, but when you're looking for the tension, you just want to be using part of the system, one of the boxes, one of the masses. Okay, let's look at another one. So this one may look different, but it's actually the same thing. So what we have here is an Atwood machine consists of 2 masses, 1 and 2, connected by a string over a pulley. Find the acceleration of the masses. M1 is equal to 3.1 kilograms and M2 is equal to 4.4 kilograms. So what I'm going to first do is I'm going to draw a free body diagram. Force of gravity, and this one is M1, so this is going to be equal to 31 newtons, and then force of tension. And this one here is force of gravity. This one is equal to 44 newtons. And then force of tension this way. Force of tension 2. Actually, the force of tension is the same because this is the same string. So this looks different. However, what I want you to do is I want you to make this the same as the last problem. I'm going to have you guys just draw it out flat like this. And then what I want you to do, instead of the force, so I'm just having you draw, so just imagine I just kind of put this flat. And then there's going to be a force of gravity acting on this one. I'm just drawing gravity going sideways in one dimension. It just makes it a lot easier, which is 44 newtons. And then for this one over here, force of gravity is pulling it this way, 31 newtons force of gravity. Okay? And then we know this one experiences a force of tension, and then force of tension this way. Now we're trying to find the acceleration, and remember acceleration, we're looking at the whole system. So sum of all forces in the x is equal to mass times acceleration x. So we have force of gravity, negative force of gravity because that's going to less, times force of, plus force of tension, minus force of tension, plus force of gravity is equal to m1 plus m2 acceleration. Force of tension cancels out. This force of gravity is minus 31. This one is plus 44. Mass is 3.1 plus 4.4 acceleration. And then we get the acceleration is equal to negative 31 plus 44 divided by 3.1 plus 4.4. We get 1.73 meters per second squared. Now that we found the acceleration, what we're going to do is we're going to use one part of this to find the force of tension. Again, remember tension, you're going to be just isolating one of the masses. So sum of all forces in the x equals mass times acceleration x. In this case, we have force of gravity minus force of tension equals mass times acceleration x. Force of gravity is 44. Force of tension, we don't know, we're looking for that. The mass of this one here is 4.4. And the acceleration is 1.73. We know it's accelerating this way. So we do a little bit of math. Let's see. 4.4 times 1.73 minus 44. And we get that tension is 36.39 newtons. And you could have used also this one if you want to, but you'll get the same exact answer. So I'm not going to show that twice. Okay, let's do another problem that's similar to this, because it might take a little while to get used to. M1 falls from rest and hits the ground in 2.2 seconds. If the height it started from was 0.7 meters and M2 is equal to 5 kilograms, what is M1? Okay, so first of all, we're looking for what the mass of this is. This one's a bit tricky. So what we have to do is we have to first find the variables we need to know. So initial velocity is 0. Displacement, the y, is going to be falling negative 0.7 meters. Hits the ground in a time of 2.2 seconds. So when it gives you information like this, a lot of times what it's helping you try to do is try to help you find the acceleration. So we're going to look at our formula sheet, and we're going to see this formula here allows us to find acceleration. So displacement the y equals initial velocity yt plus 1/2 ayt squared. Displacement y negative 0.7 is equal to 0 plus 1/2 a, which we're looking for, time, which is 2.2 squared. Do a little bit of math. 0.7 times 2 divided by 2.2 squared equal to 0.29, negative 0.29 meters per second squared. Okay. And now once we know that, again, we want to draw it in one dimension. It just helps when it's in one dimension, makes it a lot easier. So we have this one here. We have connected to this bigger one here. And we don't know what the force of gravity is. This is going to be some mass that we don't know, times 10. This is going to be the force of tension, which we also don't know. Force of tension. But we do know the force of gravity going this way, going down this way, is going to be 5 times 10. So 50 newtons. Another thing we do know is that it is going to be accelerating this way. So I'm just going to go accelerating this way, 0.29 meters per second squared. Now that we know that, let's try to look at the whole system to find what this mass is. Sum of all force in the x equals mass times acceleration x. Let's go from here. Negative force of gravity plus force of tension minus force of tension plus force of gravity equals m1 plus m2 acceleration. This one is minus 50. We don't know what force of tension is, but we do know they cancel out. We don't know what this force of gravity is, but we know this is mass times 10. This mass is what we're looking for. And this is going to be equal to m1, which is 5, plus m, which we're looking for, times the acceleration, which is 0.29. I made this positive because I just have this consistent with this, making it go to the right over here. Okay, let's try to simplify this as best as we can. Minus 50 plus m10 is equal to 5 times 0.29, which is equal to 1.45 plus m.29. I'm going to put all the m's in one spot. So I'm going to bring this over to the other side. Negative 51.45 is equal to m.29. And bring this to the other side, so it's going to be minus 10. M is going to equal 51.45 divided by 429 minus 10. It's going to be equal to 5.3 kilograms. Okay. So it took a little bit of work, a lot of algebra there, but that's how you basically do it. Alright, let's look at another example now. A 3.5 kilogram block on a smooth tabletop, so this is smooth, meaning no frictions, is attached by a string to a hanging block of mass 2.8 kilograms. The blocks are released from rest and allowed to move freely. Find the acceleration and tension in the string. Okay, again, when we're doing this, we want to draw it in one dimension. So I'm just going to draw one dimension like this. And I guess I'll just kind of draw dotted like that. So what I have is, I have it like this, and then like this. So I'm just drawing this. Force of gravity of this one, hanging block is 2.8, so this is going to be 28 newtons. Then this is going to be a force of tension. This one, there's a force of gravity going down like this, and a force normal. But the only thing affecting it is this force of tension. For the acceleration anyway. So let's find the acceleration first. We're going to look at the whole system for that. Sum of all force in the x equals mass times acceleration x. So the forces of tension cancel out with each other. So all we have is this force of gravity, 28, is equal to both of the masses, 3.5 plus 2.8 times acceleration. We get the acceleration is equal to 28 divided by 3.5 plus 2.8. 4.44 meters per second squared. Okay. Next part, now force of tension. Well, all we're going to look at is one of these. So I'm just going to look at this one. And let's just look at that. Sum of all force in the x. Remember, for tension, we're just going to be looking at one component, not both of them. So the only force in the x direction is force of tension. The mass of this one is 3.5 times the acceleration, which is 4.44. And we get 15.56 newtons. Again, I could have just isolated this one and found that one, but I decided not to. Okay, part B is a little bit more confusing because it says find the acceleration tension if the table had a coefficient of friction of 0.4. So this is where it gets a bit more confusing. So it's going to be the same thing, except what we have is we have friction now. So let me just draw this out. Same kind of drawing. A lot of things are the same. Force of gravity equal to 28 newtons. Force of tension. Force of tension, but now there's also force of friction. Force of gravity of this one, which is 35 newtons. Force normal, which is also 35 newtons. This time what I'm going to do is I'm going to figure out what this force of friction is. And I know force of friction is equal to the normal force, 35, times the coefficient of friction, 0.4. So force of friction is equal to normal force times coefficient of friction. So 35 times 0.4 equal to 14 newtons. Now, when I'm finding the acceleration, I'm looking at the whole system. Sum of all forces in the x equals mass times acceleration in the x. So I have, I'm just going to go 28. And I don't have to worry about the force of tension because they cancel out with one another. But force of friction minus 14 is equal to the mass of both of these, which is 3.5 plus 2.8. So let's see. 28 minus 14 divided by 3.5 plus 2.8 is 2.22 meters per second squared. Kind of a coincidence of why it's exactly half, but yes. Next is, again, we're just going to be looking at one part of this, and this time I'm going to just look at this part to find what the force of tension is. It doesn't matter, I could use either one. Sum of all forces in the x equals mass times acceleration in the x. So all the force we have is 28 minus force of tension equal to the mass of this one, which is 2.8, acceleration, which is 2.22. And then I get force of tension is equal to 2.8 times 2.22 minus 28, 21.78. 21.78 newtons. Okay? So again, to do these problems, it's easiest to just put it in one dimension like this. Acceleration, you're going to be looking at the whole system. Tension, you're just going to be looking at one part of the system. Okay? Alright, last one, combining everything we learned into one problem. A 3 kilogram block is on a slope that is angled at 30 degrees. It is connected to a hanging mass of 0.5 kilograms. If the coefficient of friction on that ramp is 0.08, what is the magnitude of acceleration of the 3 kilogram block? So I'm just going to kind of draw the forces out, and then we're going to look at all this. Force of gravity. Normal force. Force of tension. Force of friction. And then for this one, force of gravity, force of tension. Okay, so again, what I'm going to do with this problem is I'm going to put it all into one dimension. So I'm going to draw it like this, and the hanging block like this. So I'm going to shift this over. So now I'm going to shift this, so the force of gravity is going to look like this. And this is 3 kilograms, so this is going to be 30 newtons. Force normal is going to look like this. Force of tension is going to look like this, and the force of friction is going to look like this. Well, as long as it's sliding up, the force of friction is going this way. Force of friction might be going this way if it's sliding down, so we'll see in a second. And then this is connected to another block like this. Force of gravity, force of tension. And maybe I'm going to draw the string in orange. Okay. First, let's find the components of everything we have. Force of gravity of this, so this is 0.5. So this is going to be equal to 5 newtons. We know that this angle here is going to be the same, so this is going to be 30 degrees. And this force of gravity in the y is going to equal 30 times cosine of 30. So 30 times cosine of 30 is going to give us 25.98. And this force of gravity in the x direction is going to give us 30 times sine of 30, which I know is 15 newtons. I also know, I also know that this normal force is the same as this force of gravity in the y direction because they have to cancel out because it's not moving in the y direction. So this is also 25.98 newtons. Okay, so this gets a little bit tricky actually. So we see that the force of gravity in the x is 15, and the force of gravity here is 5. So that means there's more force pulling this down than it's pulling going this way. So this block is actually going to want to slide this way. And if this block is sliding this way, what that means is the force of friction is going to go that way. Okay? So I drew this force of friction wrong. The force of friction is going to be going this way. And what I know about the force of friction is it's going to be equal to the normal force, 25.98, times the coefficient of friction, which is 0.08. Times 0.08, and we get 2.08 newtons. Sorry, that's a bit messy. But now we can find what the acceleration is. We're going to look at the whole system, and we're going to be looking at everything in the x direction. What we have in the x direction is we have this force of gravity going this way. We have force of tension going the other way. Another force of tension going to the right, so plus. And then we have force of gravity in the x, plus. Oh no, actually that's going to the left, so that's minus force of gravity in the x. And we also have force of friction going to the right, so that's positive. So there's a lot of forces here. M1 plus M2 accelerations. This is a hard problem. Force of gravity, this is 5. We don't know force of tension, but they cancel out. Force of gravity in the x, minus 15. Force of friction plus 2.08 equal to the mass of 1, which is 3, plus 0.5 times acceleration. Alright, let's put this all in our calculator, and we'll finally be done with this chapter. 15. We get acceleration of 2.26 meters per second squared down the incline. Anyway, this is a hard chapter, so I hope you guys were able to learn. But if not, rewatch the videos. I know it'll be easier the second time around. Thanks for watching.